All right, in this video, we are going to be talking about significant figures. Significant figures are going to be one of those things that we are going to use all year long in chemistry. So significant figures have to do with the precision of a number, or actually better worded would be of a measurement. So you're not necessarily going to use significant figures in math class, but you will use them in labs because they are used to show the precision of a measurement. Now, if we take very precise measurements, we can have a very precise answer. If we have more estimated measurements, your answer can only be estimated. So significant figures will help us determine how we should be rounding all of our answers. And we are going to work with that in our next video. In this video, we are just going to work with, here's a number, look at it, determine how many significant figures it has. And then again, next video, we'll apply that to rounding. So the reason why we use significant figures is because we need to talk about the precision or, the precision of our measurements. So when we measure the mass on the balances, our balances go to 2 decimal places, and you'll notice that that last decimal place, which represents 1/100th of a gram, shows a lot of fluctuation. So as you breathe, you'll see that last digit changing. So the last digit that you're writing down in a measurement is estimated. So if we're using our balances, we only know down to the 10th of a gram, and then that 100th of a gram has some estimation, and that's going to affect how precise our answers can be. All right, so this example here, we have a paper clip, and we certainly know that this paper clip has a length of, between 2 and 3 centimeters. So we're perfectly certain that it's 2 something centimeters long. And then if we look a little bit closer, we would be 2 point, we're not quite at the 4, so we'd be 2.38 centimeters. Now, if somebody else said 2.39 or 2.37 or even 2.36, that would be close enough. So what we're getting at here is we know the 2. We know the 0.3. This last digit there is what we are estimating. So again, that last digit that you're writing down does have a little bit of error, a little bit of a plus or minus range built in. So our main goal with this video is to be able to look at a number and figure out how many significant figures it has. Because based upon the number of significant figures in our data, that's going to determine how many significant figures can be in our answer. So our first rule, all non-zero numbers are significant. So if we have a number like 152 centimeters, that would have 3 significant figures. If we were 2.39 centimeters, like that last example we just did, that would have 3 significant figures. All right, next rule, zeros sandwiched between significant figures are always significant. So what I mean by that is, let's say we have 803 grams. That would be 3 significant figures. The 8 counts because it's not a 0. The 3 counts because it's not a 0, and that 0 got sandwiched in between them, so that is also going to count. Now you could have 1,006 kilograms. That would be 4 significant figures. So not a 0, not a 0, and then both of these zeros got sandwiched between, making them count. That sandwich could spread across the decimal. 5 grams. And that would also be 4 significant figures. So not a zero, not a zero, and both of those got sandwiched. Okay, next rule here, zeros before the first non-zero are not significant. They can be thought of as placeholders. So let's look at an example of that. Let's say we have 0.15 kilograms. This only has 2 significant figures because that first zero comes before the non-zeros. It has to be there to maintain the place value, so it's not going to count as a significant figure. So we need it to keep the mathematical quantity, but it's not going to count as a significant figure. Another one, 0.0038. That would also only have 2. So both of those zeros that come before the 3 are not going to count for significant figures. Our last rule, number 4, zeros at the end of the number sometimes count, sometimes don't. They only count if they are after the decimal. So what I mean by that, and let's clear some space down here. Okay, so let's say we have 200. That only has 1 significant figure. When you say 200, it kind of feels like an estimated number. So those zeros at the end have to be there to maintain the place value so they don't count. Another example, 580. That would be 2 significant figures. That 0 at the end isn't going to count because it has to be there to maintain the place value. And it's at the end and it's not a decimal. However, if we have something like 15.0, that's going to be 3 significant figures because that 0 was added for emphasis. It was not added to maintain the numerical value. It was added to say that we know our measurement down to the 10th of a gram or whatever it is that we were measuring. So that's going to be 3 significant figures. Another example would be 571.90. Again, that 0 at the end has been added for emphasis, so this would give us 5 significant figures. Now, we are totally fine to just go by those rules that we just did. So if those rules make sense to you, that's fantastic. You can use them. This just offers us a little shortcut in case those rules were confusing to you. So this is called the Atlantic Pacific Rule. You want to treat your paper like a map of the United States. Atlantic Ocean over on the right-hand side, Pacific Ocean over on the left-hand side. So when you look at your number, like 200 that we had on that previous page, there's no decimal there, so the decimal's absent. So we are going to approach the number from the Atlantic side, and you can't start counting until you hit something other than a 0. So we would count the 2 and only the 2. So it would have the 1 significant figure. If we had 571, I think was a number we might have had. Again, no decimal. We approach from the Atlantic side. We start counting on the first thing that's not a 0. That would be the 1. You count that, everything afterwards, so that gives us 3. All right, if the decimal is present, then we approach it from the Pacific side. Again, starting with the first thing that's not a 0. So let's say we had 50.0. Decimal's present, so we come from the Pacific side, the left-hand side. We start counting with the 5 and then everything afterwards, so that gives us 3 significant figures. We had an example like this, 0015. That would be two significant figures. Decimal's present, so we come from the Pacific side, and we can't start counting until we hit something other than a 0. So that would be the 1, and then you count everything after that. So this rule will work to just make things a little bit easier for us. So 0.00150, that would be 3. Again, decimal's present, so we come from the Pacific. Can't start counting until we hit something other than a 0. So that's the doesn't count. Not a 0 doesn't count. Counts, counts. The 0 was added for emphasis, so it counts. All right, now we just have some examples. So we just need to go through and say how many significant figures we have in each one of these numbers. You can either use the rules or the Atlantic Pacific shortcut, doesn't make a difference. All right, number 1 has 3. So not a 0, not a 0, that 0 got sandwiched. Or if you did Atlantic Pacific, there was no decimal present. So decimal was absent. So we come from the Atlantic side. We start counting with the 3, everything afterwards. Either way, we get 3 for our answer. Number 2, take a look at that. Do it either based on the rules or the shortcut. And hopefully you get 4 for the number of significant figures present. Decimal is present, so we come from the Pacific Ocean. We start counting with the 6 and everything after that, giving us 4. Or if you did the rules, not a 0, not a 0, not a 0, so those all count, and then that 0 is sandwiched in between, so it counts as a significant figure. Number 3 would also be 4 significant figures. So not a 0, not a 0, not a 0. That 0 counts because it was added for emphasis, not to change the mathematical value of it. Or you use the shortcut, decimal's present, we come from the Pacific, start counting the first line, it's not a 0, that would be the 5, and then you count everything after that. Number 4, this only has 2 significant figures. So the 2 and the 5 definitely count because they're not zeros. These zeros do not count because they were before the first non-zero. They have to be there to maintain the value of the number. Or decimal's present, so we come from the Pacific Ocean, and you can't start counting until you hit something other than a 0. So we start counting with the 2 and then continue on. Number 5, that one has 4 significant figures. So decimal is present. So we come from the Pacific Ocean. Start counting with the first line, it's not a 0. That would be the 8. And then you just keep going. So that first 0 didn't count because it had to be there to maintain the place value, but the last 0 did count because it's at the end and a decimal. It was added for emphasis. Number 6 is a little funky because we don't normally write 200 like that. Normally we would just write 200, and that would only have 1 significant figure. 200.0 would have 4 significant figures. 200 point looks a little bit odd the way it's written. That would have 3 significant figures because that decimal has been added. So decimal's present. So we come from the Pacific Ocean, start counting with the 2 and everything after that. All right. Last thing, scientific notation. We are going to be reviewing scientific notation this unit because we will need it for some of our calculations. When you are determining the significant figures present in a scientific notation number, you just have to look at your coefficient out front to determine the significant figures. Obviously, the 10 to the 21st will affect the magnitude of the number, but as far as significant figures go, just look at your coefficient out in front. So 1.50, That would be 3. So this has 3 significant figures. Again, the reason why we are looking at significant figures is based upon the measurements that we have. That is going to determine how we are going to round our answers based on the number of significant figures they have. So you have to be good at looking at numbers and saying how many significant figures they have so that you know how to round your answers.